Now that you have learned the three forms of a linear equation and the properties that they show, we're going to talk about specific lines that are called parallel and perpendicular lines. You've likely heard of them before, but we want to know how each of the equations that we've already learned will help us identify if the lines are parallel, perpendicular, or neither. If we look at these three equations down here, we notice they all have the 3 in the front of the x. Remember, when we use our slope-intercept equation, that spot is reserved for the slope. This means that each of these lines has the same slope. They'll have the same steepness, if you will, if we were to graph them. But we notice their y-intercept would be different. So for example, this might be the 1, this might be the 2, and this might be the 3. We do know, though, they will never touch because they start at different points and have the same slope. We refer to these lines as parallel. Now those were easier to see, but let's talk a little bit of vocabulary here. We're going to start with parallel. We would say parallel means the lines never cross. That's because they have the same slope. Those ones are easier to recognize, but there are other types of lines that are called perpendicular lines. Here you can see 2 examples. Perpendicular lines meet at 90 degrees. They cross at a specific measurement. So it could be an undefined slope up and down with a 0 slope, just like your x and y axis make on your graphs. But it also could be slanted. Note here that this line is sloping positively and this one is sloping negatively. But not every set of lines that meet crossing positive and negatively make 90 degrees. We're going to talk about what makes that so special and how do we know if it makes a 90 degree. We call this perpendicular when lines make a right angle. Or we also call a right angle 90 degrees. That's what it means to be perpendicular. So again, an example might be 2 lines like this, where we know they make 90. The way we know that, though, is if one of the slopes, let's say this slope, was 2/3, and that's positive, so we know it could be a 2/3 potentially, this slope down here would definitely be a negative, and it just so happens that if it's perpendicular, you flip your fraction. So that's what a reciprocal is called. A reciprocal is when you have a set of numbers in a fraction and you flip them. I like to think of it as flipping the values of the fraction. So for example, if I was giving another reciprocal, I could say 4/7 or 7/4. Those are reciprocals. It's important to note that perpendicular lines do have reciprocal slopes. That is, the fraction numbers switch spots. However, reciprocal has nothing to do with positive or negative. That comes into play when our slopes are perpendicular. A positive slope must be perpendicular to a negative slope, of course, unless it is a vertical and horizontal line. So let's see what this really means with an example. They're going to give us an equation, y equals 3/4 x minus 2. That is one line. So just in general, it would kind of look like starting at a -2 and sloping up 3/4. Something like that in a basic sketch. They want us to make a different equation in slope-intercept form that goes through the point 8, 9. That can be a lot to think about, and if you wanted to get help, you could graph it. But what I like to do is remember that although point slope is newer to us, you're going to want it to be your friend. So let's think. If I want to be parallel to this line, that means I want to have the same slope. So my slope will have to be 3/4 because I'm going to be the same slope as this line if I'm supposed to be parallel to it. Also, it wants me to go through the point 8, 9. Hey, I have a point and a slope. If we remember how to create our point-slope equation, we are on our way to creating slope-intercept by doing the distribution method. So right here, you have created an equation of a line that's parallel to this 3/4 x minus 2, but also goes to the point 8, 9. That's the beauty of point slope. But now to get it into slope-intercept form, we're going to do our distribution property and have 3/4 x minus 6 equals y minus 9, and of course add 9 to get y alone. My slope-intercept equation would be 3/4 x plus 3. This line is parallel, as we note the slopes are the same, and starts at a positive 3 on the y-intercept instead of a negative 2. We have created a parallel line that goes through 8, 9. Now we want to talk about being perpendicular. Note that they say be perpendicular to this graph. We know the slope of this graph is 1/4. So now we must remember what it means. If our slope is negative 1/4, a perpendicular, and this symbol right here stands for perpendicular, kind of looks like an upside down T. The perpendicular slope is the opposite sign, so instead of going negative, it would go positive, and we would flip the fraction. That's what we call the opposite reciprocal. This will be our new slope, and we want to go through the point 1,7. Again, point slope is your best friend. If we can be efficient at creating those, it'll make our job a lot easier. Notice how 4/1 was my perpendicular slope, but I'm just going to write 4 for ease of multiplying. So now when I multiply my 4 through, I get 4x minus 4. And if I add 7 to both sides, I get 4x plus 3. This line would be perpendicular to the line they gave us, and also go through the point 1,7. You may wish to pause the video at this point to check out the try at number 3, but one thing I'll note is that I wanted a perpendicular line to a slope of 2. So my perpendicular slope would not only be a positive, it would turn to negative, but it would flip 2 to 1/2. Remember, 2 is the same as 2/1, so when I flip it, I get 1/2. I proceeded to use point slope and multiply through to get my final slope-intercept form of a perpendicular line that goes through 4, 5. Finally, we're going to get 2 types of linear equations. So here we see we have a slope-intercept, and here we kind of have a mess. We actually don't really have a form, but we could easily divide by 3 here to get our y alone. If you divide by 3 on one side, you have to divide everything on the other side by 3. So I'd be left with negative 4/3 x plus 2. They're asking us, is this parallel, perpendicular, or neither? Well, check out the slope here of negative 3/4 and the slope here of negative 4/3. You might be thinking perpendicular because, hey, the 4/3 becomes 3/4. But remember, to be perpendicular, if one of the slopes is negative, the other slope is going to have to be positive. Therefore, we would say this is neither. Down here, I have a slope of 2 and a slope of 1/2. It's nice that 2/1 flipped to be a positive half, but it didn't change signs, so this one as well is neither. Whereas in this case, I know my slope here is negative 5, but this one's written in standard form, so I'll have to do a little thinking to figure out what the slope is. You could find your intercepts like we did with standard form by making x 0 or y 0 and then counting the slope. But your best bet might be to try to get y alone and set it into slope-intercept form. So I'm beginning by subtracting 25x from both sides, and if I divide everything by 5, I'm given y equals negative 5x, because 25 divided by 5 is 5, and a positive 1/5. We don't so much care about the y-intercept, but if we look at negative 5, and we already had a negative 5, these two lines would be parallel.